Springtime on Paris. It is très beautiful, n'est-ce pas? Well, it may be spring in Paris, mate, but down here in Australia, it's autumn. Spring here, fall there, it is incroyable. That's true. It's all because of the Earth's seasons. Regarde, it is Bill Nye, the science guy. Bill Nye, the science guy.
Bill Nye, the science guy.
Bill Nye, the science guy. Science rules. Bill Nye, the science guy. Inertia is a property of matter.
Bill Nye, the science guy.
The seasons. It gets cold in the winter. Flowers bloom in the spring. We get lots of sun in the summer. And leaves fall in the fall. See, the Earth's seasons affect every living thing on Earth. That's right. Seasons affect the way everything grows and changes every year. The reason we have seasons on Earth is because the Earth is tilted. Now let's say that this is the Earth. And there's an imaginary line going through the middle of it called the Earth's axis. It's tilted, and it stays tilted as the Earth goes around the sun at 100,000 kilometers an hour. That's 1 billion kilometers every year. Now, not only is the Earth going around the sun, but the Earth is spinning. And when you're in the part of the Earth that's toward the sun, it's daytime. And when you're in the part of the Earth that's away from the sun, it's nighttime. Now, the seasons work in kind of the same way. When the part of the Earth that you're on is tilted toward the sun, it's summertime there. So when it's summertime here at Nye Laboratories, on the other side of the world, it's wintertime in places like South America and Australia. Hey, Bill, your shoe's untied. Oh, thanks. Then, when the part of the Earth that we're on is tilted away from the sun, it's wintertime here. And it's summertime on the other side of the world. Isn't that wild? All because the Earth's axis is tilted. That's the reason for the seasons.
Do you notice, though, that the axis about which the Earth turns is not straight up and down. It's tilted to one side, at an angle of 23.5 degrees from the perpendicular. This has a lot to do with why we have different seasons, as we shall see.
Let's say that this plastic globe of science is like the Earth, and we have two solar panels mounted on it. Now, solar panels convert light directly into electricity. So right now, these two panels are making enough electricity to run these two little motors. Now, right now, both motors are going about the same speed. Now notice that we have one panel in the northern half of the Earth, the northern hemisphere, and one panel in the southern half of the Earth, the southern hemisphere. They're both receiving about the same amount of light. But let's say it's summer here at Nye Laboratories in the northern half of the Earth, the northern hemisphere. That means that the Earth would be tipped toward the sun about like... Now look, the motor in the southern hemisphere is just barely moving. The motor in the northern hemisphere is spinning like crazy. Now let's say it's 6 months later, and the Earth is going around the sun so that its axis is tipped this way. Now look, it's reversed. The one in the south is going wild, and the one in the north is slowed way down. See, what that means is that this panel in the southern hemisphere is receiving more light, more energy from the sun than the one in the northern hemisphere. It's just like the Earth's seasons, right here with the solar panel plastic globe of science.
Using a flashlight, you can see for yourself that direct rays are concentrated on a smaller area than slanted rays. This is why direct rays produce more heat.
It's hot in the summer because we get sunlight head-on, and it's cold in the winter because we get sunlight at an angle. The Earth's angle is really important. I'll show you. Get some juice can lids and paint them black. Then set them up like this. One straight up, one flat, and one at an angle. Turn on the light and wait a few minutes.
Oh, which one will be hotter?
Nah.
Okay.
This one's warmer.
Uh-huh. Careful. Watch it. Oh.
This one's hot. This one's what happens in the winter. We get sunlight at an angle, so it's colder. This one's what happens in the summer. We get sunlight head-on. Is that hot or what?
What? But some people like summer better. That's when vacation begins, and the days are longest and warmest. It's the time for swimming.
Sunrise, sunset, sunrise, sunset. Flowers grow and wilt.
Hi, please consider the following. If you had to show that the Earth was spinning, how would you do it? No spaceships allowed.
Hey, I can show you the Earth spinning right here.
No weather people allowed either. How would you do it? Well, take a look at this. Let's say that this marble is like a pendulum swinging over the North Pole of the Earth. Now, if the Earth's not spinning, the marble keeps swinging right over that black line. But the Earth is spinning. So watch. The marble keeps swinging in the same direction while the Earth turns under it. And the same thing happens with a real pendulum. If I set this bowling ball swinging, as the day goes on, the Earth will turn under it and knock these nails over. Now, the first guy to do this was a French scientist named Jean-Bernard Léon Foucault. And we call it Foucault's pendulum, or Foucault's pendulum. So what's so important about knowing that the Earth is spinning? Well, it's no big deal. It's just the reason that the sun rises and sets. It's the reason that the moon rises and sets. And it causes all kinds of weather. That's what's so important.
Okay.
Thank you for joining me on Consider the Following.
PhD fishery biologist. My job is to try to understand the mysteries around these salmon, the fish coming in to spawn and to die, and then having the young be reproduced, and see if any eggs pop out. They're ready to spawn. Okay. This all looks very gruesome and that sort of thing, but it's part of a natural process, and it takes advantage of the fact that these fish are going to die anyway. Well, this egg is not a fertilized egg. This is now we need to do the male next. Okay, good job. Now I'm going to fertilize the eggs by mixing the sperm and the eggs together. These are now in the process of fertilization, the sperm penetrating the egg. This is the fall. These fish will incubate and hatch during the winter, during the late fall and into the early winter, and release them into the lake here in late spring, about the middle to the end of June. Science rules.
Sunrise, sunset, sunrise, sunset. This is kind of weird. Right now it is a different season in the Earth's other hemisphere.
This is Alaska in August. It's about 11 o'clock at night right now. That's because it's summer and our days are longer. During the summer season, we only get a couple of hours of darkness a day. Wait a minute, August? Well, it may be summer for my amigos in the northern hemisphere, but down here in the southern hemisphere, August is winter, and it's mucho frío. So how can summer in Alaska be winter in Argentina?
Let me give you a tip. It's because the Earth goes around the sun, and the Earth's axis is tilted. So the Earth takes 1 year to go around the sun, 1 year for the winter holidays, 1 year for Valentine's Day, and 1 year for your birthday to come around. You get the idea. A year is 365 and a quarter days long, because that's the amount of time it takes the Earth to travel around the sun. Ancient cultures noticed that with each season change, the moon went through its phases 3 times. So with 4 noticeable season changes, multiplied by 3 moon cycles, they came up with 12 months, 1 year. And we still use them. Not that bad.
Thank you.
The Earth is spinning around an imaginary line we call the Earth's axis. And the axis is tilted. But here's the thing. It stays tilted the same way in space through the whole year. So watch. As the Earth goes around the sun, the tilted axis makes different parts of the Earth be tipped toward or away from the sun at different times of the year. The axis staying pointed the same way in space is the reason for the seasons. You can make your own cardboard sundial of science and see for yourself that the Earth is tilted.
The Earth is spinning, so it makes the sun come up and set every day. And that makes the shadow move around like a clock.
That's why we call it clockwise, because the shadow on a sundial goes the same directions as the hands on a clock. Of course, we could have called it sundial shadowwise.
Huh?
Well, anyway, you want this angle here to be the same as your latitude on a map or a globe.
At night, Because in Seattle, our latitude is about 48 degrees. So we used a protractor. It's like a ruler for angles. And we measured 48 degrees.
That makes this side right here parallel to an imaginary line running through the center of the Earth. So here's what you do. Watch the sun's shadow as it falls on the sundial and compare it with a watch or a clock. Make little marks.
At noon, the shadow goes across here. It's the noon line. Watch the hour line for a couple of days and check your watch. You'll see the time shift.
That's right. Noon won't quite stay noon, and 9 in the morning won't quite stay 9 in the morning. That's because the Earth is spinning on a tilt, and it makes the sun appear in a slightly different place in the sky every day. You can try it for yourself.
It takes a whole year for the Earth to go around the sun, but only 1 day for the Earth to turn itself. And you know how fast it's going? 1,600 kilometers. That's 1,000 miles an hour. Whoa! Watch this.
Watch this. If I hold this card like this, more light hits it than if it's tilted, like this. That's why different parts of the Earth receive different amounts of light at different times a year. Of course, the Earth isn't flat like a card. The Earth is round like a ball. Let's say the sun is over here. Right now, a lot of light is hitting this half, whereas up here, the light's more spread out. So right now, it would be summer here and winter there. Half a year later, be winter here and summer there. Of course, that's halfway in between. It's spring or fall. Ha ha!
It's time to play the Tilted Planet Game, a show that can take a year to watch. And now, here's your host, Ross Schaefer.
Thank you. No, thank you very much, and thank you, Jay. Is that a new tie? And you, the home audience, you know I love you. Hey, let's get started. You know how we play the game, don't you? Good. Here comes our first question on Tilted Planet. What do June 21st and December 21st have in common? What do the dates June... Yes, okay, Queen.
The solstices.
Yes, the solstices, they are...
They're the longest days of the year.
That's absolutely right. Yes, in the southern hemisphere, the longest day is right around December 21st. In the northern hemisphere, it's around June 21st. Of course, in the northern hemisphere, the December solstice is the shortest day, but it's still called a solstice. It's called the winter solstice. Very good answer. Why don't we move right along to the next question? All right, question 2. When are days and nights the same length all over the world? When are days and nights the same length? You got it already, Annie? What is it?
The equinoxes.
Equinoxes are...
Around March 21st and September 21st.
That's absolutely correct. Well played. The equinoxes are when summer turns into autumn or fall and winter turns into spring. Well, you each have a score now. We have to go to the toss-up, the big tiebreaker. Are you ready? Take your time on this question, won't you? What familiar planet has seasons that are caused by the planet's axis being tilted? The planet axis being tilted. Write your answer down. When you're ready, you let me know. Take your time. You're ready? How about you, Annie? Are you ready? Annie, what do you say?
Earth.
Okay, is your queen? What do you say?
Mars.
She says Mars. Judges?
Okay.
You're both right. You're both right, yes. Mars has seasons for the same reasons Earth does. Because it's tilted. Jay, tell them what they've won.
Congratulations! You'll carry home a case of New England maple syrup.
The position of the sun in the sky changes from day to day and from month to month, so the length of shadows changes.
Measure your shadow at the same time of day a few times a month. Make a mark on a sidewalk with a piece of chalk or on a piece of paper on the ground. See, I measured the length of my shadow on the first sunny day of every month and made a graph. This experiment takes a whole year. I dare you to try this at home.
Daylight savings. A new kind of bank. A new kind of time. Open every day from the first Sunday in April to the last Sunday in October.
Okay, here we are in the Earth Garden. Here we harvest all kinds of things to eat. plants change, as the seasons change. There's all sorts of wonderful things growing in this garden. We harvest all sorts of fruit already, and we can harvest a lot more vegetables, fruits, seeds, all kinds of things. Just look around and see what's out there. I'm gonna make like a little happy face out of it. I guess I'm gonna make a funny face with only 3 teeth. Fall's the best season. You can carve pumpkins and go trick-or-treating and get a lot of free candy. Where's his arm? It's right there. Yeah, pumpkin face. This is January in Japan. Cold. Very cold.
Well, I'm sorry to hear that, mate. But to me, December, January, February, that's summertime. Yet every year, I get these things in the mail.
So, my winter is your summer.
Spot on, mate.
That's partly because the earth is
Tilted. May I offer you some hot cocoa?
thanks.
While many of us in our country are enjoying our Christmas vacation in the snow, in Chile, children spend Christmas swimming because Christmas comes in the summertime for them.
This is the earth. This is a tilted earth. A tilted earth is why we have seasons. Any questions?
The what?
This rap's about season C, there's 4 of them.
Not just 2 or 3, but it's great to hear that's cool for us.
But you know down under it's a summer bus. And when the leaves all start to fall,
It's back to school, go one and all. Now in the spring, things start to bloom.
it's great outside, so leave your room. It's the yeah, we have 4. Oh yeah,
Revolves around the sun, it takes just a year.
that's right, only one. And just one day to rotate on its own. That's why we have 24 time zones.
We're not straight as tilted, yet we all know that the earth is tilted.
It's a really big reason. Yeah, that is why we have 4. Yeah, we have 4.
Here in Nigeria, it's autumn. And in Japan. And Alaska.
Oui, oui. Donc, Paris, c'est l'automne aussi. Down here in the southern hemisphere, it's spring, isn't it, mate? Do you know why?
Because the earth is tilted.
Tilted.
It is the tilted axis of the Earth which causes our days to be longer or shorter, and which causes the sun's rays to strike us directly in summer and at a slant in winter, giving us the 4 seasons.
Well, we're just about out of time, but I want to remind you that the planet we're on, the Earth, is going around the sun. And it's not straight up and down either. No, it's tilted. Whoa! Whew. And these things together give us the seasons. Winter, spring, summer, and fall. Well, you'll excuse me. I've got some variations in global temperatures to observe. See you around the Earth's orbit.
Produced in association with the National Science Foundation.